Hello. Good morning, everyone, and hello from Nijmegen, the Netherlands, from the Max Planck Institute. I would have loved to be in Guangzhou, but because of personal reasons, I couldn't be there. But thanks a lot for the invitation, and greetings to all of you from here. Today, I will base my talk on a multimodal approach to neural and cognitive processing of language, insights from humans and machines. As we know, language is a very salient human cognitive system, and it's also very resilient. So we know that language has adapted and is adapting to individual variations, contexts, and cultures over time. So this was the case when language evolved. We know that language today has been used by humans in all parts of the world, no matter how the conditions are. And we know that it's constantly adapting to new technologies as we speak. These developments are happening. And probably if we have to leave this universe and then the Earth and move to Mars, it will be adapting again. So I would like to claim that one of the fundamental design features of language that made language adaptive is its multimodal expressibility. So this is a view that's been coming up in the last 20 years, but is more prominent, as you can see in the high-impact journals that has been published recently. So when we look at hearing communities, we know that speakers in all hearing communities that we know of, they use their gestures, facial or manual gestures, as they speak. So we don't know any spoken language community that has stopped using gestures. We know that when we look at deaf communities, then language can emerge as some deaf people, a group of deaf people can come together and transmit their knowledge to other generations. In a very short amount of time, they can create almost a full-fledged language using all bodily articulators that subserve all functions of that we know of spoken languages, such as they have morphology, phonology, syntax, semantics, etc. So body can subserve, be expressive of all linguistic structures. So then when we look at these two types of human languages, we see that no language community uses speech only. And when we look at machine languages that have been around, because we are not the only entities anymore in the world that uses language, but now machines are also reaching almost human capacity to do so. We know that these large language models, they are also becoming more and more visual. So not only that they can integrate some object information, but we know that they are also integrated some human bodily motion into the linguistic expression, minimally facial gestures at this moment, and they will be more advanced in a couple of years. So, what's interesting for me is that these machines, even though they started machine languages, they started as text-only generative language models, they are becoming multimodal language models. So in order, if we see language adapting to machines, it's also becoming multimodal. So then we are, but in relation to or in comparison to speech or text, of course, these visual aspects of language have been less studied. So in my research, I ask, what are the contributions of expressions in the visual modality to fundamental properties of language? And I ask this in 4 domains that these are, I think, 4 fundamental domains of language. Its structure and grammar, its role in communicative interaction, its role in neural and cognitive processing that we will focus more on today, and language acquisition and evolution. So one of the assumptions in psychoneurolinguistics that have mostly started defining language only based on speech and text properties is that language is composed of combinatorial units of form-meaning mappings that are arbitrary, stable, and shared. So in these models, a speaker has a concept in mind that they would like to express, communicate to another person, like in the soap example. Meaning concept of soap is activated, and it is mapped onto some kind of a phonological, arbitrary phonological unit, soap, and then the decoder can then, map this sound unit to a meaning unit as well. So most neurolinguistic and spoken language-based psycholinguistic theories have this type of understanding of form to concept mapping and how processing occurs. And this is also somewhat similar in the start of large language models, and even in some theories that propose that human language processing is similar to large language models process language. However, I would like to say that this mapping is somewhat too good to be true, because for meaning mappings in real conversations are mostly ambiguous and might not necessarily be shared similarly across individuals. If somebody says, where can I buy a soap, they might be thinking of a bar soap, whereas the decoder might be thinking of a liquid soap, and then they would not have the same for meaning mapping. So when we look at actually in real conversations, what we see is that meaning is construed most of the time multimodally and interactively. So now I would like to give you an example what I mean by this from a conversation I encountered when I was in our summer house in the south of Turkey, and I entered into a pharmacy, and then there was a customer who went in there to buy soap, and then there were two pharmacists. So the customer said, oh, do you have soap? But in this case, like, she did a gesture like this to indicate while she said soap, meaning that she wanted a liquid soap. Then pharmacist B turns to other one, C, and he asks, do we have soap? But he does not gesture in this case. And of course, the other pharmacist, C, has not seen the gesture of the customer, and then she says, yes, we have soap, but she points to a bar soap. Then the first pharmacist understands that the C has not seen the customer's gesture, so he repeats what the customer said also with her gesture. He says, oh, she means soap, repeating customer's gesture. Then C understands what kind of soap is being meant, and then she says, oh, yes, we have it, and then she points to a liquid soap. So what we see here is that there is the use of simultaneous iconic, what we call iconic gestures with speech. So that looks like how you act on the soap. So this is different than the arbitrary sound form of the soap. And secondly, there is a cross-speaker multimodal repetition of the speech and the gesture that makes sure that there is co-reference disambiguated. So if I take all these gestural cues from this conversation, this text becomes like really hard to understand. So it looks maybe like a ChatGPT using LLMs and maybe having some hallucinations. So then we can say that without iconic and pointing gestures, joint attention on the objects, and unfolding of interactive turns, it's impossible to understand what the intended referent of soap is. So then I would like to claim that in my general view on multimodal language, these multimodality-specific visual expressions, like the ones you have seen, contribute to the semiotic diversity of multimodal language, which I think makes it adaptive to many situations. So we know that spoken languages, as I said, are characterized by having arbitrary, categorical, and sequential forms in speech. And also sign languages have, even though they are performed in the visual modality, but they also have quite a bit of arbitrary signs, categorical expressions, and sequential unfolding, of course. But in addition, both spoken and sign languages have these modality-specific visual expressions. So in spoken languages, there can be pointing, of course, like the examples I've shown. There could be also pointing to abstract spaces to refer to locations, imaginary locations or people. There could be iconic gestures, like the one you see here, like I drive to work, like a driving gesture, or like I'm pouring coffee, like an action gesture. So these indexical and iconic gestures actually are overlaid, come on top of the other arbitrary, categorical, and sequential expressions in speech, and they are used simultaneously. In addition, because our body has multiple articulators, people can use two hands and also facial expression simultaneously also with speech. When we look at sign languages, we see similar expressions. Sign languages can also use pointing signs, let's say for pronouns. They can use iconic signs. Let's say 2/3 of the vocabulary in sign languages are iconic. They look like the objects they refer to. And they show a lot of simultaneity, of course. So people can use their head and hand and other articulators, eyebrows at the same time. So then a holistic view of language, I feel like, has to incorporate all these aspects into its definition. So in this adaptive multimodal language framework, language structures expressible in multiple modalities are formed, I think, and then they play a role in all aspects of language that we have done research on, like others, are shaped by two constraints. On the one hand, they are shaped by our neurobiology, let's say multiple senses, cognition, like memory or other learning constraints. So they, help language structures adapt to these constraints. And at the same time, they also change their perception of language, of course, in these domains. And they are also shaped by the pressures of communicative interaction, so how people take turns and their questions and answers and alignment in conversation. So they are also shaped by these communicative pressures of communicative interaction. But at the same time, these multimodal structures, in turn, they also allow smooth communicative interactions. So now, in the rest of the talk, I will show you some research for this claim, of course. So what I will show you is that these modality-specific visual expressions are part of the language system during when we think of language production, when we think of language comprehension and neural processing, communicative interaction, and language transmission. They also play a role in acquisition, evolution, and language emergence. So for time constraints, I will focus on these three basic language domains. And, for the rest, I think you have to invite me again to China, and I'm also happy to come at another time. So in language production, just to start with a teaser that, people usually think that gesturing is not really necessary. It's a secondary channel to language. But actually, language production without gesturing is very difficult. So I would like to show you a little documentary that was made over my research in Belgium. In this documentary, the documentary makers actually asked some students, university students, to describe how to make chocolate mousse, a Belgian specialty, how to make chocolate mousse without using their hands. So everything is in Dutch, but you will understand that what they do, you will understand they are having difficulty, they have a lot of disfluencies trying to do this job while they are not allowed to gesture.
Voor nodig 1 tafel, enkele proefpersonen en een recept voor heerlijke chocomousse. De proefpersonen kunnen hun handen niet gebruiken, want die kleven aan de tafel. Ze krijgen een filmpje te zien waarin een 4-sterrenchef hen vertelt hoe ze chocomousse moeten maken. Daarna moeten ze proberen zo goed mogelijk na te vertellen wat ze gezien hebben.
We nemen fondant chocolade, we doen de chocolade in brokjes en we laten die smelten.
Vervolgens sloeg jij ook nog wit.
Inderdaad, praten wordt aanzienlijk moeilijker.
En dan gooit hij de eierdooier over naar het halve schelpje.
Ze proberen toch gebaren te maken.
Ja, zo wat jongleren tussen de 2 eierschalen.
Desnoods maken ze gebaren met hun hoofd.
En dan doen we het eiwit ook bij het mengsel en we draaien dat er zachtjes om.
En volgens mij was de chocomousse dan klaar.
Spreken zonder je handen te gebruiken is dus blijkbaar niet evident.
Was het goed?
Okay, so I like this video because it makes my point that very clear in one video. I also think that this is very important when we look at how practitioners actually use speech therapy. People with aphasia or some other talking problems. So usually they are told, at least in Europe, in the Western world, I know that the general practice is tell them not to use their gestures so that they could focus on speech articulation. But as you can see here, even people who do not have a language problem, they might have difficulty if their hands are restrained. So this is just the general, message to the whole speech language pathologies or practitioners. Maybe if there are some of you are out there, that please, take people's gestures into consideration and let them free if you are training them for better speaking. So that point aside, so then gesture is important in the pure articulation of speech, but what about like at the higher level structures? So do iconic gestures, the gestures that look like what we see, do they also interact with a higher level syntactic structure across languages? So we found some evidence for this years ago with my colleague Sotaro Kita. We asked people from speaking different, typologically different languages, English on the one hand and Turkish and Japanese on the other, to watch a very simple cartoon, the Tweety and Sylvester cartoon, and then just talk about it. So what we found is that like in some scenes that are about motion events, like this one, so here Sylvester swallowed the bowling ball and then rolling down the hill, we noticed that English speakers on the one hand and Japanese and Turkish speakers on the other were using different gestures. And these gestures, they were about the same event, but they also looked very similar to how their language expressed different components of the event. So English speakers, for example, they can express both manner of rolling and going down in one verbal clause, whereas Japanese and Turkish speakers, they use different verbs and different clauses to express manner and path. So what we found is that these similarities also parallel in their gestures. So this is how an English speaker gestures about manner and path.
He rolls down a street into a bowling alley.
Whereas Japanese and Turkish speakers, they separate their gestures into one manner and one path.
なんか回転しながらボールみたいに転がり落ちてやって。yuvarlana gidiyor.
So this study we replicated with different stimuli and different speakers, of course. It also makes the simple point that even gestures that look like the reference they represent, they can be, interfacing with the syntactic structures of a spoken language. So what's more interesting is that, like, following up research on this, have tested whether these differences across this time only English and Turkish exist also in blind speakers who have never seen other people's gestures. So blind speakers, when they are asked first to give them some haptic experience of motion event, asked to talk about these events, and then again they found that Turkish speakers actually mostly focus on the path of the event, whereas English speakers can focus both manner and path because manner is more obligatorily expressed in English. So these language-specific differences in iconic gesture seems driven mostly by what is in the language structure. So what about, communicative interactions and communicative intent? So another point usually people think about gestures is that it's unconscious. People don't know how they are gesturing. Maybe it's there, as I said, add-on. So we want to show that gestures are actually linked to communicative intent of message preparation, an important part of how humans, we think that humans produce language. So we asked Italian speakers to simply describe how to make coffee in the Italian style with a cafetera. Maybe some of you in Asia, they don't know this, but it requires some special device to make espresso. So we asked the, speakers either to imagine an adult that they are describing how to make coffee, or they are imagining a 12-year-old who hasn't learned how to make coffee. So it's similar to situation here where I'm imagining a big audience here. So we saw that what happened is that the more their communicative intent increased, that when they thought they were talking to a child, then they used more iconic gestures, and the size of the iconic gestures increased, and then they started using both hands, showing that actually language production is linked to a communicative intent. Here you can see how this speaker gestures when he says the coffee goes up.
Attendendo che esca il caffè ovviamente.
So it's more like a pragmatic gesture, or you know what I'm talking about. And if they imagine a child, they started using iconic gestures of how the coffee goes up.
Attendere che il caffè esca dalla parte superiore.
So, and also, like, we have again done some follow-up studies on this. We have even tried, some EEG studies that before communicative gesture, more communicative or less communicative gesture production, if we could see some brain signals that differentiate these conditions. And actually, we did find that when people are doing more communicative gestures, there is like P300 effect during the preparation stage. So what about the conversation? So what I showed you was a single production, but what role speech and gesture plays in conversation? So we know from a lot of research is that alignment is a big aspect of conversations that make people actually converge and, they help misunderstanding. So people can repeat their lexical words with each other. They can also repeat syntactic structures. And we want to know whether gestures are also aligned like other aspects of speech, or they are repeated in conversations. So to do this, we created a big data set. It was a referential communication task where a director and a matcher, they had to talk about these objects that they didn't have names. So each had these object displays on each computer screen. And sometimes one of them was the director describing one of these to the other. And sometimes the matcher became the director. So they played the 6 rounds. So we, annotated 5,000 gestures, and then we looked at the alignment in words and alignment in gesture. So what we found is that actually across all rounds, if they started aligning in speech and gesture in a certain way, this alignment was spread across all rounds. So it didn't stop in the first round, but speech and gesture alignment was maintained across all rounds. So secondly, we found a high correlation between gesture alignment and lexical alignment rate across times as well. So this shows that actually speech and gesture alignment are very integrated processes, also at the level of conversation. And we also did some experimental manipulations showing that not only this happens because not only there is gesture-to-gesture priming effect, but also lexical alignment causally affects gestural alignment. And this is a thesis of Akamine Show that's about to be submitted soon. So then what are the consequences of all these production effects in conversation or single productions for comprehension? So maybe the more of you are interested in these comprehension effects. So what are the consequences of seeing gesture along with speech for speech comprehension? So what we did is we gave some action primes to people, and then we gave them different speech gesture pairs. So in these pairs, the speech was always the same, but gestures changed. Either gesture was similar to speech, or in some cases it was either weakly related or it was not related at all. So we asked people if what they heard, like that would be chop, 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 would be similar to what they have seen. So if people can disentangle speech from gesture during speech processing, they would say, yes, and with the same timing and accuracy that they heard chop. But if gesture interacts with speech processing, then seeing mismatching gestures would lead to more errors in speech comprehension, and that's exactly what we found. And this study, again, has been replicated by different labs and by different languages. And also, we did an ERP follow-up on this, and then we found that when there's a mismatch between speech and gesture, we see an N400 effect, higher N400 amplitude compared to the speech and gesture mismatching. So then seeing gesture influences speech processing. So another aspect of gestures is that when we look at how gesture is used in spontaneous conversations, there's like a little bit of effect of gesture preceding the lexical affiliate. For example, if we go back to this drive gesture I mentioned you earlier, people start doing the gesture driving a little bit earlier than they say drive. And this was actually confirmed in this kind of multimodal corpus study that gestures precede their lexical affiliates. So then does this have some effect on language comprehension, because it might lead to some prediction effects and finding the referent resolution earlier than we hear in speech? So Klo and colleagues has actually tested recently with a visual world paradigm where there's a speaker in the middle, like doing a gesture, and while saying, let's say, the girl will eat the very good sandwich. So while she says will eat, she does like a toast gesture. So this is the target. They should be the people in the experiment, they should be looking at as soon as they find a cue in the speech or gesture, and this was a possible competitor. So, and then these will eat was accompanied, as I said, either by an iconic gesture that looked like the target, or they also had a control gesture like a grooming self-adapter gesture that would be a control condition. So when we look at the eye gaze patterns of healthy participants, this was done with brain damage and healthy participants. What we see in the healthy participants is that, of course, over time, people look at less to the video, but they start looking more to the target. That makes sense. But the important thing is that this is the eye gaze to the target with the iconic gesture, and the dots are the eye gaze to the target when there's a grooming gesture. As you can see here, people start looking at the target faster if they have seen an iconic gesture with it compared to a grooming gesture. There was a similar effect with brain damaged participants, but this effect was less pronounced. So it means before people hear the word, for example, sandwich, because here the eat, of course, gives you some clue that it's not a piano or a guitar, but it doesn't tell you whether it's, let's say, an apple or a sandwich, right? But the gesture does. So in that sense, gesture can actually precede and predict the referent earlier than the lexical item, showing that, like, when we do studies like only a single modality, we are missing an important component of how humans actually process language. So then a follow-up question is, if gesture is preceding the relevant speech item, what are there any neural processing consequences for this. So to test this, we now looked at Turkish, and we picked a grammatical aspect of language, not semantic, but a grammatical aspect, which is negation. So what's interesting in Turkish is that the verb is a morphological marker. It comes after the verb. So Turkish people say eat not instead of not eat. I'm sorry, I don't know how this works in Chinese. But what happens is that there is a certain gesture in Turkish that also means not. So it's a conventional gesture. It means like this. So I know that a lot of languages in the West, they do this for negation, but in Turkish there's a hand flip backwards for negation. But this hand gesture comes on the eat, that's before not. And there's also prosodic marker that indicates that there will be a negation marker coming. So we want to see whether prosodical and gestural markers that come before negation actually has any effect on processing of the morphological marker, not. So we did an ERP study with all these conditions, and what we found is that the ERP amplitude is highest when there is no cue, no prosody and no gesture. But then M400 goes down most when there is both prosody and gesture. And if it's only gesture but no prosody, so these conditions are different. But if there's a gesture, the processing of the verbal negation shows that it's much easier compared to when there's no gesture. So then, seeing gesture is integrated into the processing of the verbal negation, and then it helps this like after verb negation structure processing. So, and this also just for you to see how these things work in typologically different languages. And finally, I would like to mention you that we have done a lot of imaging studies to see which areas of the brain are kind of more activated, processing these semantic gestures. We have used a lot of paradigms where gesture disambiguates noisy speech or it mismatches and so on. So what we found is that in the left brain, the usual language areas, LIFG, MTG, and PSDS are also activated. And in addition, we've also found contributions from the motor cortex and the visual cortex for this integration, making it that we need a broader view of language processing when we also consider visual aspects. So I think for time reasons, I will not mention the machine study, even though we have been recently doing some studies with large language models, Gemini, ChatGPT-5, to see how much they actually understand these iconic gestures and iconic signs. And so we found some evidence that actually they can understand the iconicity of signs, and they can give high iconicity ratings that humans do. Except that they have a little bit of an object bias rather than action bias, but maybe this is for another talk. So then, what was my message today? Multimodality is a design feature of human language that enables it to be an adaptive, interactive system through semiotic diversity. So not only human language is multimodal, but machine-driven languages are also becoming more multimodal to match human capacity. And they are achieving some good success in that, if not perfect yet. So modality-specific aspects of visual expressions interact with language in production, conversations, cognitive and neural processing of language. To the extent that multimodal, unimodal processing studies might be misleading somewhat how humans process language. Visual language models have only begun to understand or produce visual iconicity, but they do so mostly mapping signs to object matching, and they cannot process them in embodied ways. This our new research is showing. However, I think to go forward, machine models of language need to be trained with gesture embeddings that we could develop by using data from motion capture, like kinematic time points, and then create kinematic vectors. to be able to understand and generate multimodal language fully. And in our department at the MPI, we are also going in this direction that maybe I can talk to you more in a follow-up study. And actually our PhD student, Lan Miao Liu, is even from Guangzhou himself. I think as humans, machines also need a multimodally diverse semiotic system to adapt fully to human cognitive, biological, and social constraints. So this adaptive multimodal human system will transfer to machines that I think that showing that both machines and humans need this semiotic diversity to fulfill all fundamental functions of language. And I would like to thank, of course, all the people in my department in Nijmegen, in the Netherlands. If you are interested in our papers, here is our webpage, of course. They're all downloadable. And here is our GitHub, department GitHub, where you can also find a lot of codes for gesture processing and analysis. And I would like to thank you so much for your patience and listening to me online. Hope to see you at another time, and I will be there for the questions on Saturday. Thank you.